G'day guys, you're back with MiracleMAX. Today I'd like to share with you a new playlist that I've started entitled Ignition Systems. Although this isn't the same format that you're used to, I'm sure you'll benefit from the content. Enjoy. You might remember last time when we were looking at charging systems, the principle that we were looking at was induction. Remember, there's two types of induction. There's self-induction and there's mutual induction. What was the difference between the two? Self-induction is created by an electromagnet when it gets turned off. In actual fact, it's very similar to this coil of wire that I've created here with a soft iron core in the back of it. It's just a chunk of cast iron, and that becomes an electromagnet when it's turned on. That's actually the principle involved with a relay. So we have a coil of wire, just like the coil of wire that I showed you, and inside there is, you guessed it, a soft iron core. So while it might be a little hard to see correctly, I'll zoom in shortly to show you. All I've got for now is a 12 volt power supply over here, which I'm feeding into my control circuit, or the control side of my relay. Remember, that's 85 and 86, and I've got a switch in between. I've also got my little oscilloscope hooked up on that control side so that I can see the switch come off and on. So just, you can hear the relay click off and on. So what we're interested in is the pattern on the oscilloscope. Let's have a look at that closely. So as I turn my relay on, it comes on. We get a pattern happening here, but notice what happens when I turn it off. We've got about 11.6 volts, that's about 12 volts-ish. But notice, have a look at this voltage, maximum voltage when I actually turn it off. So that's 22 volts. And have a look at the little kick that comes up at the end there. Look at that. Maximum was 52 volts. Back EMF. That little spike that we see right there. Just freeze that if we can. Can you see that spike there? And in this case it's only 22 volts, but we did see it before where it went up to 52 volts. Let's see if we can kick in a 52 volt one. There it was, 50 something volts. How cool was that? This little tiny oscilloscope is cool, but yeah, it certainly has its limitations. Picoscope it is not. .41 that was. 41 volts back EMF. Let's see if we can actually get a picture of that. Look at that, eh? How cool is that? Right off the screen. 41 volts. Excellent. That there is a perfect indication of what I'm referring to. You can see this little cycling, and that's not unusual. It's called ringing within a coil of wire, but it's this back EMF that I'm referring to. So when we turn it off, you see it kick up there to 41 volts. Now this little fella won't go up to 41 volts, so that's why it's right off the screen. This is called self-induction. Every time an electromagnet is turned off, it creates this back EMF. The magnetic field collapses over itself and self-induces voltage into itself, and that's why we get this massive inductive kick. So what about mutual induction? What's that?